let's briefly explore the significant advancements AI scientists have made in their pursuit of artificial intelligence. In 1950, the renowned British mathematician and computer scientist Alan Turing asked, "Can machines think?" in a scientific paper. This wasn't the first time someone had asked this question, but Turing's significant contribution was to move the discussion from theoretical and philosophical to practical and experimental terms. He described an explicit criterion, later called the Turing test, for evaluating machine intelligence. In the Turing test, a human interrogator engages in a natural language conversation with one human and one machine, both hidden from view. If the interrogator cannot reliably tell the machine from the machine is considered to have passed the test and exhibited human-like intelligence. This set the stage for modern computational approaches to AI, making his inquiry into "can machines think" a pivotal moment in the history of artificial intelligence. Then, in 1956, the term artificial intelligence was coined at Dartmouth Conference, and AI became a formal field of study. Participants at the conference agreed to bring together experts interested in neural networks, the theory of computation, and automata theory to explore if machines could simulate various aspects of human intelligence. As you can see, scientists have taken inspiration from human intelligence and aimed to impart it to machines from the very beginning. The AI research community has faced many challenges. The 1960s and 70s are known as the AI winter. Technology and data availability limitations reduced funding and interest in AI research. AI didn't make big headlines for decades, until 1997, when IBM's Deep Blue defeated world chess champion Garry Kasparov. Computer power surged in the late 1990s and early 2000s, and the Internet rapidly expanded worldwide. Almost overnight, the necessary ingredients were in place. People worldwide were churning out massive volumes of digital data, and computer processing capabilities skyrocketed. This dramatic shift proved to be a turning point for AI research. It didn't take long before Geoffrey Hinton co-published a paper in 2006 reviving the interest in neural networks with deep learning techniques. Deep learning neural networks are a type of AI that is inspired by how the human brain works. One needs lots of data and high computational power to run deep learning models. So, creating such a model would have been impossible a decade earlier. In 2011, IBM's Watson AI won the Jeopardy quiz show, showcasing substantial advances in natural language processing. AI was able to work with human language. In 2012, researchers at Stanford and Google, including Jeff Dean and Andrew Ng, published Building High-Level Features Using Large-Scale, Unsupervised Learning, a paper that advanced multi-layer neural nets, or deep neural networks. Their system excelled at recognizing cats. In 2017, the Google Brain team developed a fundamental scientific contribution, introducing transformers. This model was a significant breakthrough in natural language processing due to its use of self-attention mechanisms, allowing it to process data sequences, like text, efficiently. Then, just a year later, in 2018, OpenAI released the first version of its GPT series. This generative AI technology utilized transformers to build massive large language models called LLMs. This led to significant enhancements across subsequent versions and introduced a user-friendly AI chat interface, or ChatGPT, in late 2022. If these terms and events seem confusing, don't worry. Everything will make sense as you progress through the course.